And off we go. Hey guys. Right, first things first, Biddle. You promised the people puppies. There are those little puppies. Gesture to them in the background. So cute.
It's interesting. Puppies, what do we define as a puppy? Like these guys are getting close to like young adults now, like reading Twilight novels or something. They're about 5 months old almost. So, might be RIP in the puppy phase here pretty soon.
Oh no, but they're so cute. Oh, I'm so jealous. I wish I had a dog. Anyway, perks of living in a flat in London, no pets. Michael, welcome to the show. How's your morning going?
I'm doing great. It's nice and cool here in Virginia, but it's a beautiful day outside.
Nice. Oh, lovely. The weather here is abysmal. I feel like it just can't make its mind up. It's either pouring with rain and it's still warm, but winter in the UK, eventually it will snow and then I'll moan about that. So that's something for everybody to look forward to. Okay, let's get into it. So welcome everyone to the Keys to AWS Optimization, the show where we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Stephanie Gooch, and I am a commercial architect at AWS, and I focus specifically on telco customers across Europe.
Hey everyone, Michael Biddle. I'm a principal financial architect here for AWS, supporting our public sector customers, and have worked for years with folks like Stephanie and the rest of the optics team, who you've seen here on different episodes. So glad to see you again.
I'm glad that you call me Stephanie. That's a first. It's like me calling you Michael. It's just like, oh, it's different. It's different. And as we have another Michael today, so luckily we do call Biddle, because otherwise that's going to get, of course, confusing. I just hope there's no other Stephanies in the FinOps CFM world. Just like that is just, I am AWS Steph. That's my handle. That's my name. So today we're going to be talking about data transfer, and specifically network data transfer. There are lots of data transfers out there, and so we might be doing some follow-up episodes in a later season about kind of other types, but today it's all about networking. And we have Michael with us today. Welcome, Michael. Do you want to give a little bit of a background about what you do at AWS?
Yeah, absolutely. So I've been at AWS for about 3.5 years now. I work in our strategic accounts segment, and so I'm supporting customers like Capital One, Intuit, Expedia, Adobe, so a lot of really big customers. I focus mainly on our resilience and operational excellence initiatives. And that also kind of relates to networking and cost optimization and spend as well. On how we're building resilient architectures that follow our well-architected guidance and have cost optimization built in as a side effect of a good architecture. So yeah, that's me and kind of what I do at AWS.
Nice. I love the idea of, it's common knowledge that I always say this, where being a good architect isn't about just like making stuff secure and resilient. People always seem to forget about that cost one. So that's great to point out that being a good architect is part of that cost optimization element. So today, as always, please feel free to put any questions, comments in the chat. We want to hear from you. If you have any questions about data transfer specifically, then hopefully one of the Michaels or me can help. And otherwise, if you have any questions about general cost optimization or any kind of savings in the terms of optimization at AWS, please let us know. And so let's start in with some really basic, let's start setting the scene. Michael, do you want to kind of give an overview of what you mean by kind of data transfer in terms of like networking and services at AWS?
Yeah, absolutely. So I think the place to start is at a really high level. AWS has this concept of regions. And a region is a geographic area where we put data centers. And these data centers are grouped into things that we call availability zones. So we have a region has multiple availability zones, and an availability zone is made up of one or more physical data center buildings. And we use these for a lot of different reasons, but one of the main things is kind of separation. So each AZ has isolated networking, power, physical security. And so when we think about networking within regions and availability zones, we have VPC, which is virtual private cloud. And those span availability zones inside of a region. And so when we start talking about data transfer, we have EC2 instances running inside of a VPC, potentially across multiple availability zones. So data transfer costs apply to EC2 instances when they transfer data across an AZ. So I have an instance in US East 1A and an instance in US East 1B, and they're sending packets back and forth and exchanging data. Those will incur data transfer costs in both directions.
Nice. And so what are so today we're just going to be focusing on EC2 costs, right? So that kind of flicking between AZs. And Bill, I know you wanted to mention how you see those costs, because that is something that we hear from customers all the time.
Yeah, definitely. Like, how do you find the needle in the haystack, right? We just put a link in the chat. You guys go check it out. It's a link to one of our well-architected labs that our own Ali Whitman has helped put together at AWS, who's came on the show before. And really what it's going to do is give you insights to where is the source that your data transfer is originating from and where it's going to, along with any cost allocation tags and cost tags that you might have attributed with these instances. So for example, one engagement I ran with one of my customers where we looked at this very query, what it provided was outside of just which EC2 instances are kind of creating the anti-patterns of the top data transfer between AZs, like the 80-20 rule, right? You'll kind of see from this query when you run it, which stack of instances are kind of your most talkative between each other that are where you should drill into. But also you might find with it too is if you're a heavy S3 user, for example, like are there particular bucket names that are creating patterns that are like, transferring from one region to another, then out to the internet. And those are great opportunities to find with this. So just before we start getting too deep here, like that's your kind of tool, your first spot, I think, to go to. And Michael, you have some comments too here on how to use Cost Explorer with that. So I think the tandem of them are paired up. What do you think about that?
Yeah, absolutely. There's a number of different tools you can use to analyze your costs. Cost Explorer is definitely one. Running queries on your cost and usage reports is another one. The power of using Athena on top of your CUR is a really powerful tool to extract very nuanced and specific data out of your spend. So I think they're both great tools to be able to analyze, especially in data transfer, what's happening in your environment.
Awesome. Yeah, so big shout out to the labs. There's also, and I'm trying to find the link now, we've mentioned before the dashboards that are available that you can put on top of your cost and use report. There's also one on data transfer, which is really good. So again, lots of different options if you're new to working in the kind of cost world. Start with Cost Explorer, use that link that we've just shared, and kind of do a little bit of like, okay, do I need to worry about data transfer? Have I incurred any cost with data transfer? And then once you've done that, you might want to use things like the cost and use report to dive in and actually see, like Bill said, attribute those costs out to see where things are coming from. And then moving on, you can use this with lab. There's in the cost intelligence section, there is a data transfer dashboard. So you can start to mess around with that, get some visuals, start to look at where things are kind of coming from. Awesome. So great. That was a nice little start to seeing some costs. So let's talk about why we actually got Michael coming on the show. So Michael wrote a blog post, which I'm going to share in now. So do you want to give a kind of summary of the blog post, and then we can start to go through some elements of it?
Yeah, absolutely. So the blog post is about a pattern that we call AZ affinity. And the gist of it is you want to try to keep all of your data transfer inside a single AZ as much as possible. And it has really nice benefits in terms of cost optimization and performance optimization. So again, as we kind of mentioned earlier, when you transfer data across availability zones, that incurs cost. And availability zones are placed a distance away, a measurable, meaningful distance. So sometimes it's up to many miles, up to 60 miles. And just that speed of light in physical distance incurs latency when you transfer data. The data centers that make up an AZ are physically close to each other, and that data and that latency is usually a lot faster. So we're talking hundreds of microseconds versus 1 to 2 milliseconds. And so using AC affinity, you can both reduce the latency in your application as well as reduce your data transfer costs across AZs. And so that's kind of the gist of the pattern. And then there are a couple of different ways that you can implement it in your workloads.
Nice. I don't think I've ever, again, this is something like what we touched upon the other day with thinking about sustainability that we talked about in our last episode. I never really think about the warehouses as actual things. I still have this mindset of like, it's somewhere else. Like, I don't care about it. It's in the cloud. And but thinking about the fact that you have to actually move data from one to the other and thinking like, oh yeah, that costs money. That is a physical thing. And the time it takes, yeah. So going back to what you said earlier about this isn't just about cost optimization. This is also about well architecture and well architecting and then being optimized in there. So what are some of the things that people should start to look out for if they want to reduce their spend?
Yeah, absolutely. So the first place to start, and there's a number of different types of architectures, but a lot of customers end up using elastic load balancing as the front end for their applications. And we have a couple of different types of load balancers. We have a classic load balancer, an application load balancer, and a network load balancer, and also recently a gateway load balancer. So all of these kind of have different features, but the first one to kind of think about, and we'll start with the application load balancer. So there's this feature of ELB that's called cross-zone load balancing. And application load balancers have this enabled by default, and you can't turn it off. And what that means is that when you send traffic to your ALB, it will automatically send that traffic and spread load it across its targets across multiple AZs. So anytime you use an application load balancer, you're going to be sending traffic across AZs. So that's kind of the first consideration. So if you're using ALBs, you're kind of in this place that's going to incur cross-AZ data transfer costs. Now, customers have a lot of really good reasons to use ALBs. And so I'm definitely not saying don't use an ALB because you're going to use, get cross-AZ data transfer costs. Not at all. Right, like the layer 7 capabilities of ALB are great, and customers have really good experiences using them. But if you have a workload that's really sensitive to either that additional cross AZ latency, or you're worried about your potentially your data transfer costs, what you can look at is moving to NLB, the network load balancer. So network load balancers have cross-zone load balancing disabled by default, although you can optionally enable it. And so what that provides you is with an NLB, you get an interface in each AZ that you configure it, and then it can just send traffic to the targets that are in its own AZ. So NLBs give you the ability to keep traffic inside of an AZ and reduce the data transfer costs from your load balancing layer.
That's a great description. Sorry, I was going to caveat this whole session with I am not good at data transfer cost stuff, and so the Michaels are the pros, right? I'm just going to summarize you two. So that was a really good explanation. But sorry, I cut you off, Biddle. What were you going to say?
No, not at all. I'm actually, so here's one thing that I get asked a lot, and I think kind of we're seeing some questions in the chat too. Is like when folks hear AZ affinity, and you might read a blog post that's like, hey, limit your architecture to data transfer within one AZ or whatever, right? It's like, well, aren't we supposed to be very highly available, fault tolerant, spread across multi AZs, right? And so I just kind of want to give you a chance here to touch on that, Michael, because this architecture that you kind of illustrated in your blog post here is still highly available across multiple AZs. And rather, it's using the functions of the parameters you can use within the affinity function itself to use some smart intelligence to where it's going to disperse that data. Do you kind of want to touch on that a little bit?
Yeah, absolutely. So, the benefit of multi-AZ architectures are the resilience that they offer. You can have an entire AZ fail, maybe the fiber gets cut, power goes out, right? And you can still operate your workload within that region, nearly seamlessly. And so we really want customers to use multi-AZ architectures for those resilience characteristics. And with AZ Affinity, you can still do that. Your network load balancer can be deployed across multiple AZs. And the way that you can then help customers isolate their traffic to a single AZ is providing DNS names that indicate which AZ that load balancer interface is a part of. So again, if you have a load balancer in US East 1A, and 1B, and 1C, you can use those AZ names or the AZ identifiers, which are consistent across accounts, as part of a DNS name that your customers can use to send traffic to. So if you have another client of your service that's also in AWS, and they're in US East 1A, and you have a network load balancer in US East 1A, they can access your service using that DNS name and keep that traffic isolated to a single AZ. But if, say, that AZ is having problems, maybe your service is having an issue that's localized to that AZ, they could use the other DNS names for the other availability zones and send the traffic there. So under normal operation, when everything's going smoothly, you can keep the traffic in a single AZ. But when things are having hiccups, you can kind of break that and still maintain your resiliency and availability of the service. And so you get kind of two options then on how you interact with services that leverage this pattern.
Nice. So we've got a couple of questions in the comments. So I'm just going to throw one up. So someone's very generally put, what about high availability if we think about AZ affinity? So is there any kind of quick summary you want to give about kind of how we're talking about data transfer today and the difference between being highly available and like the specifics about AZ affinity?
Yeah, so it was a little bit of what I just touched on.
Yeah,
but, so it's really the you have to it's where you previously had one endpoint, like one DNS name where you would access a load balancer through.
Right.
You kind of break this up, and your customers, the clients of your service, also have to be aware of what you're doing,
right?
To be able to take advantage of it, or in the greatest cases. Now they can still come in through the front door, and it's as long as you silo in the back end as much as possible. You're still achieving the outcome that AZ Affinity is working towards, which is, until it's necessary. And you may have a service that replicates data across multiple AZs, and by necessity, the purpose of the service is to do cross AZ transfer, and that's totally fine. AZ Affinity is not saying don't run that kind of service. It's saying that if you don't need to transfer it and bounce across AZs and load balancers and other communication patterns, don't do that. But still leverage multiple AZs for high availability and let your customers know how they can interact with you to achieve that.
Hopefully your longer discussion, I think, covered everything. So we've got a bigger question, which I think is not about data transfer, but as always, we do like to try and answer everything. So just to summarize this question, we're planning to migrate 10 VMs across to AWS. My question is, the business case only shows 10 VMs and total compute for EC2. How do I right size those VMs to a specific EC2 family? Biddle, do you want to take this on a quick, how you would the instant recommendations for this person?
Yeah. So I'm assuming by evaluator, maybe we're referring to something like TSO Logic, which we're running in with most of our migration evaluation results. If not, definitely ask your account team to look at how you can use TSO Logic to evaluate that, because we have mathematical evaluations built into it that will tell you what the cost optimized setup would be for your on-cloud deployment versus your on-prem infrastructure. But really, from a structure standpoint, strategy, if you have these workloads that are running on the cloud, do a 2-week and 1-month baseline within CloudWatch metrics to see if those instances are hitting a max of CPU or memory of at least over 40%, right? And if they're not, you probably have found there what I would call some of the low-hanging fruit of instances. If they're not maxing over 40 in either of those two metrics, to where you can downsize it just 1 degree and probably be just fine. Michael, I don't know if you have a hot take on that.
No, I would agree. I'd say using CloudWatch and metrics for this particular instance and for lots of things are incredibly powerful tools. The dashboards, give you a really easy way to visualize your usage, and so I would definitely agree with you, Biddle. Using metrics to baseline and is a really helpful way to right size your EC2 instances.
Yeah, definitely. We see a lot with customers that are migrated that they have this kind of, we threw it on the cloud. There's not a lot of customers, it can happen to customers. They put it on the cloud and then they think, oh, okay, it's working. And then they just kind of leave it. And so a big thing is definitely, it's great that you are already thinking about right sizing. That's the best thing we want to hear. So go in there, look at these metrics. You can use services like Trusted Advisor, Compute Optimizer, right sizing. These are all native free tools that you can utilize, and start looking at recommendations. Really recommend using Compute Optimizer to go in there and start seeing what's going on. But also kind of have a look at the applications. What do they need to run? So what kind of CPU, what cores, what memory do you need? And use those. And if you look on the kind of EC2 sizings website, if you look at the information, it'll have all that information, all the different types. But yeah, reach out to us if and any questions. If anybody wants some more information and wants to chat, feel free to kind of tweet me at Lift Like a Nerd, or cost optimization at amazon.com is our email address. We always love to hear from you guys, and we can always point you in the right direction of somebody else if you need some more support from Amazon. So we have another question as well. Again, the people having the brief question today. KMS, what it can do. Biddle, go for it. I know you wanted to jump.
I mean, key management service, in regards to data transfer, healthy keys, right? If we have a key that's referenced between multiple applications, right? I guess what I would just say is is it in hygiene? Are we using only the minimally viable amount of keys for different applications to make sure you're following security procedures, right? And as far as what that relates to data transfer, I don't have a hot take on that, but another acronym that's very similar to that is MSK, AWS MSK, manage Kafka. And since we're talking data transfer, we'll just spend just a quick minute on it. Manage Kafka. So if you have in your environment Kafka running around, right, like pull all your tags, do a control F. Even if you don't know what Kafka is, just look for the word Kafka in your environment, and then have a discussion with your team and really look at that application. So if it's one where you see a pattern where, for one, if you have a high amount of data transfer costs that are between AZs within a region, right? So US East 1A to US East 1B is the example. Kafka, really what that does is it's a managed service that will take away those data transfer costs between AZs within a region for you. There are some trade-offs. It's currently not covered by a mechanism such as the AWS savings plan. So really the ideal situation for trying to save money on data transfer by moving to managed Kafka is one in which you have a lot of like maybe low utilization on an instance, but you foresee that instance is going to pick up in utilization because you have a new product launch coming, right? And so you're not going to be scaling the number of instances per se with that workload, but it's going to be hitting higher utilization as it's more used. And so like in a bin packing scenario, for example, you'll see kind of this come to play where if you're going to keep that instance count flat, but the utilization keep going up, you will see a pretty substantial return by using MSK, Managed Kafka, because effectively you're getting more out of less instances, and then you're reducing that data transfer cost, which is going to be inherently a little higher in that scenario. So that's one thing to look out for, a little tip.
Cool. I love the thing of KMS and the letters around. Being a dyslexic, I would probably have misread that one. All right, one more, and I don't know if Michael, you want to take this one. So, does AWS bill for cross AZ data traffic for RDS?
Yeah, so this is I'll answer this in two parts. So if you're using a multi-AZ RDS instance, that data transfer between the nodes in your multi-AZ database cluster is not billed. So there's zero additional costs for the transfer that happens between the two instances. Now, if your EC2 instances are accessing the RDS database across an AZ, that data transfer is charged. And so again, one of the ways that you can implement AZ affinity to help reduce those charges is using read-only replicas that are distributed across the AZs that you operate in, and focus your read operations on a read replica that's in the same AZ, and then only cross AZ boundaries to do writes when you need to. And that's another way that, it's not in the blog post, but it's another way that you can leverage AZ affinity to help reduce those data transfer costs.
Nice. This is all taking me back to my DevOps days. I haven't thought about a lot of this stuff in a while, which is great. So let's jump into some customer stories from you guys. I feel like there's a couple that you do. Michael, do you have any really memorable stories of, especially around kind of cost optimization and what customers did, or any specific things that our customers who are watching today could kind of take away and start?
Yeah, absolutely. I can. I'll start with one. So I can't mention the customer by name, but so one of the customers that I worked with was really concerned about data transfer costs, and they ended up building a single availability zone infrastructure in order to not incur those costs. They do a lot of data movement in between their workloads, or in between their instances that are all inside of a VPC. And so they went with a single availability zone architecture in order to avoid that. However, the problem is that they don't get the resiliency that multiple AZs offers. So if there's any issue inside the AZ that they're operating in, they don't have the redundancy in a different AZ to be able to pick up that workload. And so they started to be able to leverage this pattern of AZ affinity to become multi-AZ, while still avoiding a lot of the data transfer costs that they were concerned about. And so they've begun this journey in making themselves more resilient while still optimizing for cost. And it's been a great experience for them because they're getting to take advantage of more of the built-in native AWS services and capabilities that is really providing a better customer experience for their customers.
Definitely. I think the AZ affinity is the buzzword for today. Is the thing everybody needs to go and look into. So we've got. I really want to answer his comments, so we can always jump back to a little bit more time of any customer stories he has. So the same person who asked about RDS charges just wanted to check: is that the same that applies for Aurora?
Let's see, for Aurora. Yeah, so the same as for Aurora. So any in between instances that's managed by the service and data replication, that's not billed for inter-AZ traffic.
Cool, brilliant, thank you. All right, let's jump onto this one. This is a long one, and I'm gonna have to read it aloud. So I have lambdas in VPC that are pushing data to S3. Network data transfer is billed for those operations. Is there some kind of internal endpoint for S3 that would limit those costs?
Is it internal endpoint? So the gateway endpoint, so there are two different types of VPC endpoints. There are interface endpoints and gateway endpoints. Interface endpoints bill per gigabyte of data pushed over them. Gateway endpoints do not incur additional data transfer costs. Mm-hmm. So as you use like an S3 or DynamoDB gateway endpoint, that's just a kind of routing mechanism to steer the traffic to the service. But you're not billed individually per gigabyte for data transfer over those.
Cool. Biddle, have you ever seen people kind of struggle with this?
You know, I'll be honest. I am a little unsure of how I would properly answer this, but I think kind of topically under the same line of thought, right, is you see customers who will use edge locations with CloudFront and kind of some similar types of scenarios. And, you know, I've seen models where basically like if you have 100 terabytes, basically that's coming, you know, to CloudFront and then out to the internet, right? That same 100 terabytes that's going from an edge location with CloudFront to the internet versus just out to the internet, you're going to save like 12%. Roughly, more or less, depending on how much more you use over 100 terabytes, right? But I think topically on this, which is a good segue, because one of the examples I wanted to really hit on here before we kind of come up on showtime here is you're going to see examples within your environment when you are looking at the curve where besides just data transfer between AZs, like maybe you have a particular bucket type in S3 that is you're seeing commonly served out to the internet to your customers publicly. We really encourage you to look at, like, especially if that content is video, for example, let's put that in a CDN offering like CloudFront, right? You know, things like that really make a lot of sense in reducing the spread of data transfer since you're grabbing it from that cache location instead of having the whole route from S3 out to the internet. You can save you anywhere up to like 75% typically, depending on the scenario. So that's if you have one thing you're going to take away from this show and look in your environment, find videos hosted in your S3 that are not in CloudFront. You'll look like a stud. Yeah, for sure. We have I had a whole call with someone the other day about CloudFront savings, and so for season 3, I'm going to try and book them in to come and have a chat because that's apparently a massive way to save money that I wasn't even aware of. So that's great. There's more things to learn for our customers. Just in the last 2 minutes, because I did want to touch on this. Where's the thing gone? Here we go. Okay, so we were talking about this before we came online. So will there be an ability to tag data transfer costs, considering it can help split them up? Now, we discussed that there is a way. It inherits the tag from the service that it comes from. Is that right, guys? Yeah, so if it's from an EC2, it'll get the EC2 tag. If it's from an S3 bucket, it'll get the S3 tag. Yeah, it's a backdoor solution, right? Like, I mean, honestly, everything goes back to a lot of your tagging structures, right? So as long as the, source resource, and we know not everything is taggable in AWS. Generally, most everything is, but there are some that aren't. But your EC2 instances, for example, those can all be tagged. So if you have those tagged, the data transfer that happens between those and from those, you'll all be able to see in that query that we put at the beginning of the show, the source of that data transfer and the endpoint or destination it went to. So just tag your base resources, and 90+% of the time you're going to be able to allocate the data transfer. Perfect. All right, I've learned that because I was under a misconception that I did not know that. So now I know. Tag everything, and then you get the data. So we are at time. So thank you so much to both Michaels for coming on today's show. Love being able to do that. And honestly, as well, Michael, the really great explanations of
all the different services and applications. Like, thank you so much. They've been really detailed, especially for me, self-proclaimed, not good at data transfer person. Next week, we will have someone from the Insights team coming on, again, I think talking about budgets we've got next week. So stick around, check out our stream and the schedule on AWS for next week. And if not, all of our videos are on our YouTube channel, Keys to AWS Optimization. So if you've missed any and want to go back and watch, then you can go check that out. But thanks, guys, and see you all next